everyone, this is our presentation for the lecture Practice of Social Network Analytics. Our team are two people, is Songpon and Kitiwat. We will present about our movie and streaming platform recommendation. So first let me introduce our motivation for this project. Because nowadays there are many movie streaming platforms that's available in the market, whether it's a Netflix, Hulu, or Disney Plus. It's benefit for us as a customer, of course, that we can enjoy various movies from our home. But however, each platform they might not provide all movies that we want, since sometimes they have a different movie available in each platform. So for example, we might pay already apply for some platform, but we finally found out that they don't have the movie that we want to see. So we come up with the idea to make a movie network that can provide customer the information, not just movie recommendation but also platform recommendation as well, by using what we learned from this lecture, like network analysis and our community detection. So we use two datasets for our model. First, on the right side, the movie on streaming, which has the movie title and the platform that is available on. That's what we want for our model. For example, the Avenger movies, they might available only on Netflix but not available in another platform. But this dataset is not enough for us to make the network, so we combine with another one. On the left side is Stream TV movies. This one provide all the movie title, genders, country, director, actors, and many others. So that's easier for us to make the node and easier for us to connect the movie to the network. So the data set that we checking, we found out that we need some pre-processing. We need to replace an empty string to the missing data, and also separate data point to the list by use the comma mark, and change the column names so it's easier to be called. After we already cleaning all the data and pre-processing, we can create a graph. So the node are the movie itself, and the person, which means the actor and director, and also the country, and is the movie genders. And the age are the relation of the movie with the other nodes. For example, between movie and the person, between movies and gender. So as we said, the movie will connect each other by the environment, the surrounding environment. For example, if they have the same director or same actor, they will be connected through those nodes. And the next one, the method we use is Loven community detection, or as known as fast unfolding method. We assign individual community to each other node, select a pair of community and combine together, calculate with the modulation gain from the mood and close to the move with higher gains in the nearby, and then we create a super node from the community and repeat every step again. So the final result will come out with the base community. We also give a function, make a function of the performance test to test that which random state have the best performance, and from that we keep doing check the random state to find the most significant one, best result that we can get. And finally, we got the community detection result as shown. For example, like the matrix belong to the community number 1, but the pianist belong to the community number 6. But however, we found a little bit imbalance in our result. For example, since the community number 1 has a lot of the movie inside, but for some other sometimes there will be only 1 or 2 movie in that.
Hello, my name is Kitiwat, and now I will continue the presentation. So this part will be about the platform recommendation. So here we will suggest the platform according to the community. As you can see here, we will count the number of the movie in that platform according to the selected community, and then we will put those count number that we have counted uh, along with the platform name in the dictionary, and then we will use the max function to find the max value. Uh, but then we found out that the max value only returned the first max value that they found. So just in case that there is some case that there is more than two platform contains the same max value, so we created this loop to collect all of the platform that contain the max value, just in case that more than one platform contain the same max value. And then we append all of those platform into the community platform list. And then for easier use, we convert the list into the dictionary, because in the dictionary there will be the pair. So here's uh, the result of the community platform dictionary. As you can see here, the pattern of the dictionary is pretty easy to read and use. Here's an example. So the first value is the community number. In this case is number one, community number one. And here is the recommended platform, which this one is Prime. And furthermore, we can input the movie title that we want, and then we can be able to find the community number from the data frame table according to the input movie title. After we get the community number, we can find the recommended platform according to the community input value. And in this case, the Matrix movie is recommended that is recommended to use the Prime platform if you want to like watch the movie that is like the Matrix movie. Uh, as mentioned before, that the community, the resulted community is like imbalanced. As you can see in the previous graph, that some community like contain a lot of movie like thousands, and some community contain only like 100. And if we input the movie and we found that that input movie is in the same in the community that contain like 1,000 movie, then if we recommend the movie according to the community, we need to show all of the we need to like show off all of the movie in that community, which like if the input movie is in the community that have 1,000 movie, we need to recommend 1,000 movie, which I think which like we think that it's kind of weird. So we research for the better method, and the method that we found is that atomic ADA link prediction. So this method will usually use for the link prediction, by which they will measure the closeness of the nodes according to their neighbors. After that, they will like predict that the nodes that are close to each other will likely to share a link, which is the link prediction. But however, in this case, we don't want to do the link prediction. We just want to use the this closeness score of this method. So to calculate the score according to the calculation, this is the node that is existing in the vector U. So the result score will will contain the value that the value 0 means that the two nodes are not close to each other, and the higher values mean the more the nodes are closer to each other. And here we create a get recommendation function according to the atomic ADA method. So the parameter here is the input movie name. So we will receive the input movie name, and we will find the we will use that movie node as our root node. Then we will use the variable e to iterate through the neighbors of the root node, and we will also use the variable e2 to iterate through the neighbors of the e node. Then we will check that is the e2 variable is the root node or not. So if it's the root node, we will skip it, and if it's not the root node, we will check that whether it is the movie node or not, because our graph contain like many types of nodes, for example like actors, genres. So we only like focus on the movie node. Then we will use the commons variable to check whether the current movie node E2 is already in the dictionary or not. So if it's not in the existing dictionary, we will just add the new data into it, which the new data is the pair of the E2, which is the neighbor of E and the E. So it is the movie node and their neighbors. However, if in the case that E2 is already existing in the dictionary, which means that the E2 is already be the neighbor of some other nodes, we will append the current E, which is the movie node, into the commons which we get from this function, which is the like the previous movie node that has the E2 as the neighbor. So after we appended the current movie node into the commons variable will contain both previous movie node and the current movie node. Then we will input the value into the dictionary according to the previous formation, previous structure. As you can see, the E2 is the neighbors, and here is the commons, which is the owner of the neighbors E2, which in this case will contain like more than one node. So after repeat of these loops, we will get the list of the neighbors and its owner, so that we can further use the equation from the atomic ADA to calculate the closeness between each node and its neighbors. And after we calculate all of the closeness score, we will collect the movie name, movie title, and the corresponding score. And here is our example result. So in the first example, we input the root node as the matrix movie. Then it will iterate through the matrix neighbors and the neighbors of the matrix neighbors and calculate the closeness score. And here is the result closeness scores. So the most two closest nodes are the sequence of the matrix movies, which is like kind of makes sense according to our domain knowledge. And next we can like plot the result, our result in example result, into the graph. And here is the graph for the matrix example. Here, as you can see that all of the sequence of the Matrix movie are very close to each other because they are the same movie sequence, so they will share a lot of neighbors, which is the same actors, the same directors, the same movie origin country, and the same genre. However, on the other hand, the other movie that isn't a sequence of the Matrix movie uh, will be further than the sequence of the Matrix movie. However, those movies still share some common neighbors with the Matrix movie, which is why those movie will is being shown in the graph because they are the one that uh, has the highest score despite the matrix sequence. So in conclusion, our team be able to successfully done the recommendation system, both movie recommendation and platform recommendation. And however, we still can't find the way to evaluate our recommendation whether that the recommendation is efficient or not, because the movie preference is the personal justification, which is everyone has their own movie taste, which cannot be measured by some standards, and there is no right or wrong between the people movie taste. So our team hope that maybe in the future we can find a way to evaluate our recommendation so that we can improve our system and improve our method to calculate the recommendation. And that's it for our presentation. Thank you for your attention.